All right. Hi, everybody. It's Miss Mandy again, coming to talk to you this time about lenses and how they work. So, if we remember in our previous talks, we remember that we talked about reflection and refraction and how light acts. So, if we remember with our prism here, or with our rectangle glass, when we put our light in, it causes the light to slow down inside of the glass and come out at a different angle, or it causes it to like bend and bend again. Okay? So that's refraction. So we're still talking about refraction when we're talking about lenses, because light, when it goes through clear things, remember, it causes it to bend. So with this top part, I know it says to use Snell's law, but I just want to show you what it would look like if we had an actual like beam of light coming and going through our lens. So you'll notice when we do that, we have our light kind of coming in at this angle, and it bends and it comes out at a separate angle, which is toward the axis again. And if we do that opposite, it does the opposite and tries to push the light that way. So the basis behind lenses is just like that, where it has the light coming in from an object, it goes through a lens so that it bends and goes out at a different angle. Okay? This is going to look similar to our mirrors in that this is where we're drawing ray diagrams. These ray diagrams will follow a specific set of 3 rays for each lens type so that we can understand how they work and where our images are going to be. So there are 2 types of lenses. There are converging and diverging. They're based off of the convex and concave kind of idea. Converging are similar to the convex mirrors, concave mirrors. They're similar to the concave mirrors because they make the light focus in on an area, whereas diverging is similar to convex mirrors. Oops, that's not how you spell convex. Convex mirrors, because they're going to cause the light to spread out. As a basic rule, concave or converging lenses are similar to this, where they bulge out. So, for example, this right here is a converging. And diverging lenses are sunken in like this. So this is a diverging, because when the light goes in, it spreads it out. So this would be a diverging lens. So it would be like this is how it's diverging. And is that one a diverging too? Yeah, I think that one's a diverging too. Okay. Oh, I lost one of my lenses. Oh well. Okay, so we're going to focus on those 2 types of lenses and making the ray diagrams for those. Okay? So I'm going to do those, and their rules are going to follow closely the mirror rules that we talked about earlier. So I am going to use the same color scheme as before. I'm going to use red, blue, and green, to make our lines. So our first line, as always, starts off parallel from our object. So our object is over here. Let's start off parallel and draw the line. From there, we're going to go through a focal point. And with converging lenses, we want to follow the focal point. You'll notice actually that there's 2 dots. Since we have a clear thing, since our lenses are clear, the light can go through them, which means for lenses, we're going to have two focal points. We're going to have the near focal point, which is on the near side, and the focal point over here, that is the far side. So I'm marking them as FN and FF. What is going to happen when our converging light goes through here? We remember it kind of pushed it this way, which means it's actually going to, once it goes to the center of the lens, it's going to bend and it is going to go straight through the far focal point. Just like that. For our second lens, ray for our lens, it's going to do the same thing. It's going to go through one of our focal points first before it hits the lens. And before it was hitting the focal point before the mirror, this time it's going to hit a focal point before it hits the lens. And the only focal point that it can do that with is the near one. So we're going to actually use the near focal point first, draw through it, hit the lens, and remember what happens with a mirror, the light bounces off straight. So again, the blue is opposite of the red one, where it's going to go straight through. So it's going to bend and go straight parallel. It's going to end up like that. Okay, it's going to look like that. Our last ray that we want to talk to, it says goes through the center of the lens. Before we had the center of curvature, unfortunately with a lens that's not going to be possible because the lens is bending the light. So it's going to go straight through the center of the mirror this time. So I'm going to label that. It's going to be right in smack dab in the middle where the mirror center is, crossing with the axis. So this is the center of the mirror. And we're just going to line that up. Top with the center, and we draw. And it's going to go straight through. Like with our other ones, it's just going to be a straight line. And just gonna bounce right through. So this one honestly doesn't need this. I don't need that. It's just gonna go straight through the lens. So like always, the magic only happens when all three of these are drawn on the same diagram. Okay, so I'm gonna do that down here real quick, and then we'll see where they all meet up, because that's where the magic happens, is when they all cross paths. So straight, focal point, focal point, straight, and then lastly go through the center. Okay, so I quickly drew that for us. And we can see same with our mirrors. There's the sweet spot where they all meet and intersect right here. And same as with our mirrors, that is where the tip of our image is going to be from our object. So that's the tip of the arrow, and obviously the bottom has to be connected to the axis. So we draw our line, and then we finish our arrow, which is going to be an upside down arrow. So there's our new little arrow right there. I'm just going to bring it a little closer here for you so that you can see it. And then we can once we have our rays drawn and our little image drawn, we can come back to our 3 pairs of words. If you don't remember them, here they are again on my handy dandy post-it note. And we can use one of the words from each pair to describe the image altogether. So, is it bigger or smaller? It is smaller, which means it is reduced. Let's move up here. Come on. Okay. Is it right side up or upside down? It is upside down, which means it is called inverted. And now we come to real and virtual. This one was pretty like we said that before the mirror, like as in front of the mirror was real, in back of it was virtual. For lenses, it's the opposite. So over here, compared to over here, when we have light coming straight through, that is where our real images are going to be. Whereas our virtual are back here. So in this case, with a lens, this is a real image. Real. Okay? So that's our converging lenses. Okay? Like before, there are problems where you practice this. Please do those to find out where your images are. Remember to follow the rules. Start out parallel, go through the far focal, start off going through the near focal, go out straight, and go through the center. Okay, those are the 3 rules for the converging lenses. Then let's skip ahead to the diverging lenses. I'll show you what those 3 rays look like so that when you draw those, you are following the rules for those ones. Okay? So for 8, that's where our first one is, at the bottom of the second page. So with this one, it's going to follow the same rules in that we have our far and our near focal points, here and here, near and far, and the center of our mirror, the center of our lens. Sorry if I called it a mirror before. So we have the center and our focal points of our lens. And we're going to follow the same kind of rule here where we start off parallel or straight from the top and hit the lens. Now this one, instead of going through the far one, since this one is going to make the light go out, we're going to be putting it through the near focal point. We're going to line it up, the refracted ray with that. So it's going to make the light do that out of the lens. But we're going to, same as our previous mirrors with the convex mirrors, we're going to draw virtual lines backwards through the lens, through the focal point, the near one. Okay, so the light is going to do that. Okay? So that's your first ray. And some of you might be going, are you sure that's how it behaves? And I can show you how that is how it behaves. Just give me 1 second. Retrieve my lens that I lost, that I dropped. Actually, I didn't drop it. Where did it go? Where'd my other one go? There you are. Okay. I can show that here. So we can see here that it comes in and it gets diverted out that way. Okay. All right. Next ray. Oops, sorry. Turn the page. Next ray, we use blue like before. And this one is going to follow the same rules where instead of coming off straight, it's going to come and go through the focal point. But since we already kind of went through the close focal point, we're going to be using the far focal point as the thing we line up with this time. So here's our far focal point, near focal point, center. Line up with that. Goes in at an angle. It's going to hit the lens and it's going to go off straight or parallel to the surface again. So it's going to go off. Oops, that's totally not straight. I'm so sorry. It's going to go off straight. But same as before with the first one we drew, we are not going to stop there. We are actually going to make virtual lines in the back that goes out straight. Again, I'm sorry, that's not straight. But it should be straight out like that. Comes in angled, goes through straight, and we make the straight real straight virtual lines back. And then our third ray is the same as always, where we line up with the center and we go straight through. This one we don't need to make any virtual lines because the light goes straight through. Okay. And as always, this is not where you need to draw all three rays in order for it to, make sense, where we can see where all of our lines intersect. So I'm going to do that here real quick. So red one starts off parallel, hits, goes through the near focal point, or lines up with the near focal point. Like this. Blue one goes and lines up with the far focal point. Draw it. Goes through straight, but we make virtual lines in the back. Last one goes through the center. So hopefully you made that on your own as I was doing it, and we can see the magic moment that our virtual lines this time are making a intersection here. So that's where our little arrow or arrow image is going to be. Okay. Same as before, we can use our three pairs of words to describe the image. Is it bigger or smaller than the original? It is smaller, so it is reduced. Is it right side up or upside down? It is right side up, so it is upright. And lastly, real and virtual. Remember, it is opposite to the mirrors. Remember, over here is the virtual side and over here is the real side for lenses. So in this case, this one is where the virtual lines meet up. So that means it is virtual. Okay. Same as before, we have more examples of practice making your diagram, putting all three ray diagram lines on there, finding where they meet and drawing your image. and giving the three characteristics, like characteristic words for your arrow image. And the math stuff, I will go over later, but for most of you, for today, we're just focusing on drawing and finding our images. Okie doke. Those are the basics behind your lens ray diagrams and how to make them by doing the ray diagrams, following these rays here for your converging lenses and these ones here for diverging lenses. Okie doke. All right. And that should do it for ray diagrams for lenses. So, if you have any questions, please let me know. Otherwise, that should take care of it. Take care, everybody. Bye-bye.